Hello everyone, welcome to the SR Maths Learning channel. This video we are doing based on the classical definition of the probability. Here we are going to discuss some conceptual problems based on the classical definition of the probability. In my probability video 1, part 1, I discussed the classical definition that if A is an event, the probability of an event A is equal to number of favorable outcomes divided by total number of possible outcomes. Total number of possible outcomes. So this is the classical definition of probability of an event. So very clearly we know that probability of an event is always greater than or equal to 0 and less than or equal to 1. So please do remember this. So based on this, we are going to solve the problems. So let's see the first problem. A pair of fair dice rolled. Find the probability of getting a total of 6. A total of 6. So we know very clearly if two dice, pair of dice in the sense here, two dice, if two dice are rolled, the sample space, number of elements in the sample space is 36. Right? That means n of s is equal to 36. Let A be the event. Let A be the event of getting a total of 6. That means when we are throwing two dice, so the number comes up, summation should be some x and y, that x plus y should be 6. That's what they're asking. So let's see what we have the outcomes whose sum is 6. So we have 1 comma 5, 1 plus 5 is 6. Similarly 5 comma 1 also, and 2 comma 4 and 4 comma 2 and 3 comma 3. So these are the possible outcomes whose summation is 6. That means n of A, we have 5 total. 1, 2, 3, 4, 5. So n of A is 5. So probability of the event A getting the sum of 6 is n of A by n of S. That means these are the number of favorable outcomes to us. These are the favorable outcomes. So there's n of A and the total outcomes is 36 n of S. That is 5 by 36. Therefore, probability of getting a total of 6 is 5 by 36. So hope you understand clearly. So let's see the next question. So the question is three distinct numbers are selected from first 100 natural numbers. Find the probability that all the three numbers are divisible by 2 and 3. So here what they are given question is three distinct numbers are selected from first 100 natural numbers. Find the probability that all the three numbers are divisible by 2 and 3. So whichever we are selecting the three numbers from the first 100 natural numbers, the three numbers should be divisible by 2 and 3 it seems. So first of all, total number of ways. So total number of ways of selecting these three numbers. How many numbers they are given? 100 numbers they are given. From the 100, we should select three numbers. That can be done in 100 C3 ways. This is our sample space n of s. So now, what is our favorable outcomes? What is the discussion here? Whatever we are selecting that three numbers, those are divisible by 2 and 3 it seems. So divisible by 2 and 3. That means That means the numbers should be divisible by 6 because LCM of 2 and 3 is 6. So what are the numbers from 1 to 100 we have which are divisible by 6? 6, 12, 18, like this. Up to 96, we have the numbers. So total number of numbers we have, n of a is equal to 16. So 16 numbers are there which are divisible by 2 and 3. So now from this we have to select our favorable cases here. So total 16 numbers are here. So out of this 16, favorable outcomes to us is we have to select the 3 numbers from this 16. That can be done in 16 ways. So probability of getting 3 numbers divisible by 2 and 3 is equal to favorable outcomes 16C3 divided by total number of outcomes 100C3. So 16 into 15 into 14 divided by 100 into 99 into 98. So by 3 into 2 into 1, that is cancelled. So here 4 4s are 4 25s are okay. So 5 5s are 5 3s are, so 3 1s are 3 33s are, so 2 7s are 2 49s are, and 7 1s are 7 7s are. So finally we got to 4 by 1155. So probability of this one is 4 by 1155. So hope you understand clearly. So let's see the next question. So the question is, the letters of the word assassin are written down at random in a row. Random in a row this. Find the probability that no two S occur together. So these are the questions based on the permutations and combinations. So let's see what they're given. The word is ASSIN. So total number of ways of arranging this. Total number of ways. How can we arrange here is total how many letters we have? 3 plus 3 plus 2, 8. So that can be done in 8 factorial by. In this 2 A's are there. Yes, we have 4. So that's why it's repeating letter size. So divided by 2 factorial into 4 factorial. This is our total possible outcomes, N of S. So total 8 letters we have. 8 letters in total. In this 8 letters, S we have 2. Yes letters we have 4. So that's why the total number of ways, how can we arrange this is 8 factorial by 2 factorial into 4 factorial. Now let's see what are the favorable outcomes. So first, let's arrange AAIN, because they told very clearly no two S occur together. They are given. That means S letters should not come side to side. So that's why remaining letters we will arrange. What are the remaining letters after leaving the 4 S letters? AAIN. So this can be arranged in 4 factorial by, since 2 A's are repeating, by 2 factorial. So that means here we are arranged these 4 letters. So among these 4 letters, we have 5 blanks. 1, 2, 3, 4, 5. 5 blanks we have. So these 5 blanks by 4 Yes, we can arrange in 5C4 ways. We can arrange in 5C4 ways. That means 5 ways. Right? So which is about 5C1, it is 5 ways. So total favorable outcomes. What are the total favorable outcomes we have? 4 factorial by 2 factorial into 5. Right. So what is the probability? So what is the probability we will get here? So probability of this event P of no two S occur together. So this can be favorable outcomes. Favorable outcomes we have here 4 factorial by 2 factorial into 5 divided by 8 factorial divided by 8 factorial by 2 factorial into 4 factorial. So if you simplify this, we will get 1 by 14 as the answer. So this is the probability of no two S occur together when SSN written down in random row. So hope you understand clearly. So let's see the next question. So the question is, a divisor of 2700 is selected if the probability that it is a multiple of 4 but not 5 is 1 by p. So then find the value of p. So let's find out how many divisors we have for 2700. So 2700, if you will do 2 1s are 2 3s are 2 5s are 0. So 2 6 are 2 7s are 2 5s are. Next with 3 3 2s are 3 2s are 3 5s are 3 7s are 3 5s are 3 2s 3 5s and 5 5s. So we can write 2700 as a product of prime factors, 2 square into 3 cube into 5 square. So if you calculate the number of divisors for this, number of divisors will be 2 plus 1 into 3 plus 1 into 2 plus 1. That means 3 into 4 into 3, total 36. This is your sample space, total number of possible outcomes. So now what they told, so our favorable outcomes, what they told about the favorable outcomes. So the probability that it is a multiple of 4 but not 5. It is a multiple of 4 but not 5, they told. So that means we should not select this. So we can select only this in one way. So here 4 and here 1 way. So that means 1 into 4 into 1. So because if I'll select 5 and 2, the 5 and 2 combination 5 into 2, 10, which is divisible by 5. Even if I'll select 1 5 also, that is divisible by 5. So that's why we should not select this. This can be done in only one way. This can be in 3 plus 1 ways, and this is one way. Total 4 ways we can select the favorable outcomes. Hope you understand why we are not selecting this 2 and 5. 2 into 5, 10. So you'll get the multiple of 10, which is divisible by 5. But here they told very clearly it should not be divisible by 5. It should be divisible by only 4. So that's why the favorable outcomes will be only 4. So the probability of the event A, where it is a multiple of 4 but not 5, is favorable outcomes by total outcomes, 4 by 36. That is 1 by 9, which they are given 1 by p. That means p is equal to 9. So the value of p is equal to 9. Next, if 3 distinct numbers are selected from first 30 natural numbers, then what is the probability that their sum is divisible by 3? So how many numbers selected? 3 distinct numbers. So 3 distinct numbers selected from first 30 natural numbers. So find the probability that their sum is divisible by 3. Okay, right. So generally 3 numbers, how can we select? So total possible ways. So 3 numbers, how can we select from 30 natural numbers is in 30C3 ways. This is our sample space. Now, see that 3 numbers should be divisible by 3 means. So how can we take? Let's see which kind of numbers we can see. So out of these first 30 natural numbers, some are 3n form, some are 3n plus 1 form, some are 3n plus 2 form. So that means 3n plus 1 form means like 3, 6, 9, 12 up to 30. These are 10 numbers available. So next 3n plus 1 means 1, 4, 7, these kind of numbers, 10 numbers. So next 3n plus 2 means 2, 5, 8 up to 29, these kind of numbers 10. So now the selected three numbers should be divisible by 5 means if I select the three numbers from only this, whatever 3, 9, 15 like that, 12, 27. So it is divisible by 3. So either I can select from these, the whole three numbers, means our digits will be like A, or I can select all the three numbers from this B also, because 1 plus 4 plus 7, 8, 12, it is also divisible by 3. So that's why there is a chance of getting B. And all the three numbers are from C also, we can select. So 2, 5, 7, I mean 2, 5 is 7, 7 plus 8 is 15, which is divisible by 3. So we can select all the C. Or from each, we can select one number. That is also, the sum is divisible by 3. Means what are the possibilities, favorable outcomes? Here possibilities in the sense, favorable outcomes. That is nothing but favorable outcomes. What we have favorable outcomes here? I can select all A's only three numbers, or all the B's I can select, all the C's I can select, or one from A, one from B, one from C. So that means I can select all the three numbers from A, means that can be done in 10C3 ways, or B from B 10C3, or C 10C3, or 1 from A means 10C1 into 1 from B 10C1, 1 from C. So these are the favorable outcomes. So now the probability is 3 times of 10C3 plus 10C1 whole cube divided by total 30C3. Total 30C3. So this is the answer. Even you can simplify this also, but right now I'm leaving this here only. So let's see next question. Two fair coins are tossed. Two fair coins are tossed. Find the probability of getting at least one head. First of all, this is basic question. When two coins are tossed, so what is the sample space we will get? Heads, tails, heads, both are tails. Means our n of s will be 4. But what is asking? Find the probability of getting at least one head. At least one head in a sense. At least one head means we can take minimum one head, or I can take two heads also. So here the favorable outcomes for this, at least one head means heads, heads. Two heads is head. So if here n of a will be 3. So probability of happening this event is 3 by 4. 3 by 4. So this is the way how we will solve this question. Next, 10 fair coins are tossed. Find the probability of getting 3 heads. First question. At least 5 heads or majority of heads. 5 heads, 5 tails comes alternatively. More number of heads on the first 5 coins than the last 5 coins. So let's see the first one. How we will get the 3 heads? So first of all, how many coins are tossed? 10 coins are tossed. 10 coins are tossed. 10 coins are tossed. That means our sample space will be 2 power 10. 2 power 10. So here, how we will get the 3 heads? So 3 heads means remaining all tails. 3 heads means remaining 7s, we can get the tails. So 7 tails. So generally 3 heads, 7 tails can be arranged in 10 factorial by 10 factorial by 3 heads are repeating, 7 tails are repeating. This is nothing but a 10C3 ways. These are the favorable outcomes. Favorable outcomes means out of 10 heads, 10 tosses. So 3 we have to select 3 heads in 10C3 ways. So probability of getting 3 heads is 10C3 by 2 power 10. 10C3 by 2 per 10. What is the second question? At least 5 heads. So second question is at least 5 heads. At least 5 heads we should get. So how you will get the at least 5 heads? So at least 5 heads means P of at least 5 heads. At least 5 heads means we can take 5 heads, probability of 5 heads. I mean 5 heads taking plus 6 heads plus 7 heads plus 8 heads plus 9 heads plus 10 heads divisible by sample space. So 5 heads, how can we select? In 10C5 ways. Out of 10, 5 heads. So out of 10, 6 heads. Out of 10, 7 heads. Out of 10, 8 heads and 9 and 10. This is the way how we will select. Whole divided by 2 power 10. So this, when I'll add and subtract 10C0 to 10C4. So it will be converted like NC1 plus NC2 plus so on NCN is equal to 2 power n. So like this it will be. So NC0 plus NC1 plus NC2. So how can we write this one is, when you will convert it to 2 power 10, it can be written as 2 power 10 plus 10C5 by 2 power, by 2 power 10. That means 2 power 10 plus 10C5 by 2 power 11. So this is the way how we will get the probability of at least 5 heads. So what is the next question? Majority of heads. It is also very similar to the previous question. Majority of heads. Majority of heads. That means more heads should be there. So probability of getting the majority of heads is, how can we take heads? 10 out of 10 heads. So 9 out of 10 heads, 8 out of 10 heads, 7 out of 10 heads, 6 out of 10 heads. So 5 we cannot take, because when you will take 5 heads, 5 tails, it will be equal. They are telling majority of heads. So divided by 2 power 10. So this can be written as 2 power 10 minus 10C5 by 2 power 11. As per the formula, 2 power n is equal to NC0 plus NC1 plus so on plus NCN. So by using this. So next, what is the fourth question we have here? So when 10 fair coins are tossed, 5 heads and 5 tails comes alternatively. 5 heads, 5 tails comes alternatively. So how we can take this? So means we can start with heads, tails, like this. Or we can start with the tails, heads, and tails. Means there are 2 ways. So these are the favorable outcomes, only 2 ways. So what is the probability? Is 2 by 2 power 10, which is 2 power 9. So this is the 5 heads and 5 tails comes alternatively. So next, so what we have? More number of heads on the first 5 coins, then on the last 5 coins. So this is the condition. Probability of getting more number of heads on the first coins. So on first 5 coins, and on last 5 coins, So how can we take? So on first 5 coins, if I take 5 heads, last 5 coins either 4 or 3 or 2 or 1 only, or 0 number of coins, right? Heads. Here if I take 4 heads, here 3 or 2 or 1 or 0. If I take 3 here, your 2 are 1 are 0. If I take 2 here, your 1 head are 0 heads. If I take 1 here 0 heads. So how can we take this? So out of 5 coins, 5 heads. So we can take 5C, 5S into here this one. Out of 5 coins, we can write like summation of R is equal to 0 to 4, because up to 4 coins only we can select out of 5 coins. Plus, next, out of 5 coins, 4 coins can be selected in 5C 4 ways. And this summation of R is equal to 0 to 3 5CR. Plus next, 3 coins can be selected in 5C3 ways. That is summation of R is equal to 0 to 2 in 5CR. Plus next, 5C2 ways here. Here only summation of R is equal to 0 to 1 5CR. Here 5C1 ways into 5C0 ways. So if you calculate this all, the favorable outcomes will be 386. So probability of this event is 386 by 2/10, which can be written as 193 by 512. So this is the probability of getting more number of heads than more number of heads on first 5 coins than on the next 5 coins. So hope you understand clearly. Thank you all for watching my videos. So please subscribe to my videos to get more number of videos, and thanks for watching.